So the first equation has multiplication by 6. The inverse of that is to divide both sides by 6, leaving us x equals 3. Number 2, we need to first reverse the subtraction of 10. So you add 10 to both sides, leaving 3x equals 12. Then divide both sides by 3. We're left with x equals 4. Number 3. We have x's on both sides, so I choose to subtract x from both sides, leaving us 7x minus 10 on the left, which is equal to 11. The inverse of subtracting 10 is to add 10, leaving 7x equals 21. Divide both sides by 7, we're left with x equals 3. Okay, and number 4, we have x's on both sides. So if we subtract 5x from both sides, we're left with negative 7 is equal to 2x minus 17. Add the 17 to both sides, giving us positive 10 is equal to 2x. Get rid of the multiplication of 2 by dividing both sides by 2. X is 5. Number 5. Again, there are x's on both sides of the equation. Since negative 2 is the lesser amount of x's, I'm going to add 2x to both sides. So 5x plus 9 is equal to 44. Subtract 9 from both sides, leaving 5x equal to 35. And when you divide both sides by 5, your solution is x is equal to 7. Lastly, number 6. Again, x's on both sides. I subtract 1x from both sides, leaving 2x plus 6 is equal to 2. Subtract the 6 from both sides. 2x is equal to negative 4. And divide both sides by 2. We're left with the solution of x is equal to negative 2. Starting with number 7, we have a pattern. So I count up the number of tiles in each little picture. Step 1 has a single tile. Step 2 has 4. Step 3, 7. So what I notice right away is that there's 3 additional tiles in each of the little pictures. Well, since number 7 asks us for the total tiles in step 5 and step 6, the easiest thing to do here would just be to continue adding 3 to get the total for step 4 and step 5, 6. So that leaves me with step 5 having 13 tiles and step 6, 16 tiles. When I get to number 8, I'm now asked to write an expression or a formula that can be used to find the number of tiles in any step. Now there are at least 2 different ways that I could see writing this. So when you get to numbers 10 and 11, you will probably already have written one of the 2 formulas at number 8. The first thing that I see could work is the formula 1 plus 3 times the quantity n minus 1. I get that 1 from step 1 having only a single tile. So I start off with just 1 tile. I include the plus 3 because that's the pattern that I identified above, that each step adds 3 more tiles to the previous total. Now I'm multiplying by n minus 1 here. N stands for the number of step, and I'm subtracting 1 because I didn't add 3 for every step, but rather for every step after the first one. So in other words, for step 2, I've only added 3 once. For step 3, I've added 3 twice, and so on. So I can use my formula then to determine the number of tiles in step 25 by just replacing the n with a 25. So that becomes 25 minus 1 is 24. 3 times 24 is 3 times 24 is 72, and then 1 plus 72 is 73. Okay, so in numbers 10 and 11, we're asked to analyze two formulas, two expressions to represent the same pattern. Well, one of these you probably already used for number 8. So if so, don't feel the need to go through it again. For me, I used the formula at number 10 already. But once again, to go through the meaning, the 1 is because we started with one tile in step 1. The plus 3 is because each step adds 3 more tiles. N represents the step number, so I'm multiplying by the quantity n minus 1 because you didn't add 3 tiles for every step. It's one less than the step you're on. For example, at step 2 you've only added 3 once. At step 3 you've added 3 twice. For step 4 you would have had to add it 3 times. Now in number 11, this is a new expression, 3n minus 2. Well, the 3, positive 3, once again represents the 3 tiles that are added for each step. The variable n, once again, stands for the step number. The difference here is that we're not subtracting 1 from the n. We're assuming that we have added 3 tiles every single step, including to get to step 1. Well, how would that happen? If you added 3 just to get to a total of 1 tile at step 1, we must have started with -2 tiles for what we could refer to as step 0.